It is I who proudly feed 2/3 of the Asian and half of the world population. That's right, I am a mighty rice plant. Most, if not all, living organisms on this planet have their own nemesis, and I'm no exception. Rice planthoppers, who feed only on my juicy stems, leave a hopper burn on my body while spreading deadly diseases. In fact, they can contribute to up to 30% of overall losses in global rice production every year.
水稻上的病毒相当于是人类说的癌症，那么这样它就基本上就没法治了。
The most widely adopted solution so far is pesticides, but they just bring too much ecological burden. And it harms you too. Yes, you, rice-eating humans.
很多农药会致癌啊，然后把我们整个生态系统破坏掉。因为它不仅仅对害虫没有这个致死作用，事实上它也可能对生态系统当中其他的生物可能致死。
Scientists realize they must seek a new solution, simply by asking the plants.
In the past decades, scientists have discovered that many plants, including rice, are capable of summoning the enemies of their attackers by releasing invisible substances into the air. The logic is plain and simple. The enemy of my enemy is my friend. But understanding this sophisticated process is no easy task. Luckily, Professor Lo Yonggan is an expert in plants language. In Lo's lab at China's Zhejiang University, researchers employed this unique device to collect and study one specific substance released by rice after they're bitten by planthoppers, Lanaluo. The smell of it is very appealing to parasitic wasps.
寄生蜂它可以根据这个挥发物找到这个寄主，然后呢，寄生蜂它会寄生这个寄主，然后使得这个寄主就这个害虫就死亡。
This self-protective mechanism gave scientists an idea. If they could figure out what triggered rice to release Lanaluo before pests even began to bite, the lovely little wasps would show up even sooner to kill the hoppers. So Lo and his colleagues embarked on a quest for a molecular compound to make it possible, a process of reverse engineering.
所以这样子利用这个方法，我们可以对很多的小分子化合物进行筛选。那么从这些化合物中找到了就有一个石头苯氧乙酸。那么这个化合物最后我们发现它可以诱导水稻释放方状层。
The artificial substance was mixed into the soil and was gradually absorbed by plants. Scientists soon detected a significant increase of Lanaluo, and hoppers in the lab also died soon after. But there wasn't a single wasp in the lab. So who killed the hoppers?
那我们在一次偶然的发现中呢，我们制作了水稻叶鞘的不同时期的切片。我们把这个切片呢，通过共聚焦显微镜来观察，我们发现，在4.5天以后呢，水稻的薄壁细胞中出现了很多的颗粒状的沉积物。
稻肥是它一个自吸式口气的害虫，所以它要取着水稻，它是取着水稻里面的嫩皮部的汁液。那么它这样子进去的时候，它必须要掺和细胞的。
That means the chemical that's supposed to trigger plant to release more Lanaluo just unexpectedly formed those little physical barrier inside the plant to block the planthopper's needle-like mouth parts. Imagine drinking a cup of bubble tea, but the entire straw is filled and blocked by loads of tapioca balls.
这样子呢，这个稻肥子就是水稻呢，就基本上就被饿死，活活饿死。
A lab experiment that turned out even better than what researchers had expected. But applying this method to farmlands may still be a long shot. Professor Lo said one way would be to spray the leaves with the artificial substance, which can be easily done with agricultural drones. Another option is further explore molecular mechanisms and uses to genetically modify rice plants so that the plants can self-activate insect resistance without any external treatment. Either way, this preliminary lab success has yet to be translated into agricultural use. But when it does, scientists believe it could revolutionize the way rice is grown across the world.
那么我们这开发出的这个小分子化合物呢，它对于昆虫是没有直接作用，而是要通过把植物的抗溶性给激发出来，然后才能够导致昆虫死亡。所以相对于讲，它这个比原来的一些化学农药更安全、更绿色。